everybody. Welcome back from spring break. Yay, I know that you're so excited to get started again. But it's downhill from here to the end of school, so yay. Okay, the first thing we're going to do before we even start our notes is do our I will statement. Today we'll find the lateral and total surface areas of prisms and cones. So today's section is 10.4, lateral and surface area of prisms. So we have a few vocabulary words that I need you to write down first. The first one is lateral, which means no bases, areas of the side faces only. And actually, now that I think about it, if you want to pause this, go ahead and write everything down, draw it if you wish, and then come back, that's fine, so that we can talk about it and you can actually look at what you've gotten written. But anyway, lateral means that no base is included. You're only getting the area of the side faces only. Then you have surface area, which is the total surface area. You may have seen it as TSA. Areas of all the faces added together. This includes the bases. And this is surface area of all the faces that you can see, okay, like when you hold it. In other words, you add the base of it and things like that. But if you've got two things stuck together like composite figures, if you can't see the bottom of, for instance, a top cylinder, then you won't include that. We'll go over that some more. The lateral edge of your prism, okay, lateral edge being right along here, not the edges of your bases. A right prism, when it stands straight up, okay, the height of it makes a perpendicular line to the base. A right cylinder means that the height inside the cylinder is also perpendicular to the base. So right cylinder, right prism, think of the right angles. And then the oblique prisms, there's at least one lateral face that is not a rectangle. This is because usually it's leaning over. As you can see here, the height is a perpendicular distance actually outside of the prism. And when it leans over, it kind of makes a parallelogram, usually more so than a rectangle. And then you have the oblique cylinder that's exactly like the prism where it's leaning over a little bit here, okay? But the height is still outside that makes a perpendicular axis to the base, okay, or to the ground. All right? So those are the vocabulary words that you need to remember. I know that you've done these before, but just a quick memory there. All right. So here, you got this in class. We thought we'd make it a little easier on you and go ahead and give you all the formulas as well as a few little examples here. But just to remind you, lateral and surface area of a right prism. Right because the height makes a perpendicular segment to the base. The lateral is going to be L, it's represented by L, and it equals the P times the H. Sorry, I'll zoom in so you can see it. L equals big P times H. The big P is the perimeter of your base. Okay, it's the perimeter of your base. The surface area of a right prism with lateral area L and base area B is, okay, so you have the total surface area. You have lateral, that's with a big L, total surface area with a big S. This equals L, which you got from here, L plus 2 times the area of the base, or you can plug in this formula for lateral again to get to there, plus 2 times the area of the base. And then you're familiar with the cylinders, where you have lateral is just the 2 pi r. Remember, that's the circumference around the base times the height. That's going to give you the area of maybe the label, if you want to call it that, label of your soup can, for instance, just around the outside. And then the surface area is going to be that lateral surface area plus the area of your two bases, hence the 2 pi r squared. Okay? All right. And then at the bottom down here, we gave you some examples when you work with dimensions that have been multiplied by a scale factor. Okay? So you're going to want to look over these examples and kind of have an idea of the effect that it has, but we'll work through a couple here. All right. Now, on the left side of your book, if you want, you can go ahead and fold up your foldable. It's up to you how you fold it. I just folded mine where the inside was blank, just like we've done before, and then I folded it down like this so that number 1 is on the front. Okay? All right. Zooming back in here. All right. So it says find the lateral and surface area of the regular hexagonal prism round to the nearest tenth. Okay, at this time, if you want to go ahead and pause me, you can do that, write all this down. I'd kind of like you to do that so you can kind of watch what you have written while we talk about it. So go ahead and do that now. All right, let's work this together. The lateral surface area. Remember the formula was big P times H, so perimeter of your base times the height. Okay, that gives me the label around my soup can, if you will, okay, which equals 360 meters squared. The total surface area is going to be that 360, because that was around the outside, which, by the way, is this piece right here now. And now we need to find the area of our polygonal bases. All right, so we have hexagonal bases. That's where your 1/2 apothem times perimeter comes in. You have to pull out your little right triangle just like we did before. This could actually use special right triangles instead of decimals, depending on what your answer is supposed to be in. But here I did tangent of 30 equals the opposite over adjacent to find my apothem. When I cross multiplied, I figured out who needed to be divided by whom, and you get 5.2 when rounded. Plugging it in, 5.2 for the apothem and 36, because 6 times 6 is the perimeter, 36 gives you 93.6 meters squared for the area of your base. Okay, then you just have to go up and you plug it in, so you have 360 from the previous lateral surface area, 93.6 for the area of your base, plug it into the formula for the total surface area, and you get 547.2. Okay? Then, let's see. This one is a composite figure. All right, find the surface area of the composite figure. This is the one I was telling you about, that you're going to solve it just like normal, except this little base that's inside there, he's not going to be included in total surface area because you can't see him. You have to think of surface area as if you were holding something and painting all the edges. You count everything you would paint. So on the surface area of the cylinder, you have 2 pi rh, that's the circumference times the height, plus 2 of your bases. Okay? So that's just finding the surface area of your cylinder in general. Now, yes, in a minute I actually subtract out one of those bases. You could have done that here and just done pi r squared. Works either way. The total surface area of the rectangle is the perimeter times the height. So perimeter around the bottom gives you 26. Height is 5. Then you have 2 of your base areas, which 9 times 4 is 36. You solve it and get 202 centimeters squared. So then I added them both together, 202 plus 62.8, and I got 264.8. Don't forget, I used the actual formula here, so I have 2 bases, and I need to subtract one of those out to give me 252.2. Okay? All right. This number 3, if you want, obviously you can go ahead and copy that down, but I think I'm going to go on to this one so that I can, because the other one I know you can totally figure out just by doing an original and a new. But here it says the height and diameter of the cylinder are multiplied by 1/2, hence the scale factor is 1/2. Describe the effect on the surface area. Okay, so we're not doing volume yet, just the surface area. And when they only say surface area, you do total surface area. Okay, the original here, let's see, we have to actually just come up with some dimensions because they didn't give us any at all. They just want the effect. So I came up with 1 for my diameter, 2 for my diameter, 4 for my original height. Okay? So I plugged it in for the total surface area of a cylinder, 2 pi rh plus 2 pi r squared, because you can pick this one up. So 2 pi times the radius of this one is 1, and the height of this one is 4. And then I have 2 pi times radius squared, which the radius of this one was 1, so I get 1 squared. 8 pi plus 2 pi gives me 10 pi. Then the new one, I divided everything by 2 or multiplied by 1/2, whichever one. So I have now a diameter of 1, height of 2. So 2 pi r, which would now be 1/2, plus a height of 2, plus 2 pi r squared. Okay, remember we're using the green numbers now. So when I reduce it, I get 2 pi plus 1/2 pi equals 2.5 pi. Okay. So then, when I do this, I go, okay, well, I went from 10 to 2.5, so what was the scale factor that got me there? Actually, this is a little easy way for you to figure it out. You can put the new over the old, and divide them out, and you find out that you have 0.25 or 1/4. So that tells you, just go back and compare it to your original scale factor. 1/4 is 1/2 squared, okay? 1/2 squared. We changed both of them. Both of the dimensions, more than one, so it's scale factor squared. Sorry about that. All right, and then of course you can go back and finish copying this one down if you want to, but make sure you understand how to do it, okay? Make up your dimensions, affect them by the scale factor, plug it into the formula, and then find out what was the effect on it. And you can always do new to old and figure it out that way. Just make sure you understand what that means, okay? All right, that's all for these notes. I'm going to go ahead and make a second recording for your 10.6 notes. So have a good time doing your math, and I'll see you in just a bit.